What's up, everyone? Welcome back to my channel. Today, I'm excited to share a project that took me over 10 hours to complete, but has fundamentally changed how I think about web hosting and cost optimization. We're going to dive deep into a production-ready AWS static website architecture that solves real-world problems while keeping costs incredibly low. This is the exact same architecture that Fortune 500 companies use for their corporate websites. By the end of this video, you will have built something that would cost $100,000 plus if hired as a consulting project. But we're doing it for under $5 per month. We'll cover the complete architecture, walk through each component with real implementation details, discuss cost optimization strategies, and at the end, I will show you a live demo of the automation scripts that I built to deploy this entire infrastructure in minutes instead of hours. Let me start with a real business scenario that every company faces. We need a professional website that loads quickly, worldwide, costs under $5 per month to run, handles traffic spikes during marketing campaigns, and can be updated easily by our marketing team. Does this sound familiar? This is the exact problem I solved, and here are the specific challenges we'll be addressing. Challenge number 1, global performance at a scale. Traditional web hosting often struggles with global performance. A user in Australia accessing a server in Virginia experiences 3 to 5 second load times. That's unacceptable in today's market where users abandon sites that don't load within 1 second. Challenge number 2, cost versus performance trade-off. Most hosting solutions force you to choose either compromise on performance for a cost or pay premium prices for decent speed. Shared hosting at $10 to $20 per month gives you terrible performance. VPS hosting at $50 per month requires server management. Premium CDN services cost $300 to $500 per month. Challenge number 3, reliability and uptime. I've seen too many businesses lose revenue because their hosting provider went down during a product launch or marketing campaign. Single points of failure are everywhere in traditional hosting. Challenge number 4, SSL and security complexity. Many solutions make SSL certificates expensive or complex to manage. Some charge $100 plus per year for basic SSL. Others require manual renewal that teams often forget. Challenge number 5, deployment and update nightmares. Traditional deployment processes are manual, error-prone, and time-consuming. I've seen teams spend entire afternoons just updating a simple website, introducing a bug in a process. Our AWS solution eliminates every single one of these problems while delivering enterprise-grade performance for the cost of a monthly coffee. Here is the static website that I built. Files hosted in the S3 bucket. CloudFront is what's putting the website out across the world or select regions. When you type in sethpetty.com, it comes to the landing page with, "Hello, I'm Seth, cloud consultant, specializing in secure and cost-effective cloud solutions, passionate about automation, infrastructure as a code, solving complex business challenges." Coming down, infrastructure as a code, security compliance, monitoring and optimization, serverless architecture, featured projects, multi-tier web application serverless data pipeline, CI/CD pipeline, AWS certifications, planning, AWS cloud practitioner is what I'm going for. I already taken the AWS Cloud Practitioner course on Coursera. I just need to finish taking the exam, and I'll get the certificate for that. So I'll come into the About section, About Me, technical skills that it's listing, education certifications. I do have certifications through Coursera, Course Careers that I still need to update into this website. Yeah, coming to the projects page, static website with global CDN. That is what this is. So this was the first project that I completed. And I'm going to be starting on this multi-tier web application next and coming to the contact page. Now, when setting this up, it was somewhat of a pain. Ended up putting in the contact form I have it connected to every time you hit send message that it will go to an API and tell Lambda to send a connection to AWS's simple email service, and they will email the users saying that I'll reply within 24 hours. So just to test it out because I know it took a while. Come over here, point testing. So send a message. Once it's sent, thank you for your message. I'll get back to you within 24 hours. This is the architecture breakdown of it. So let me show you the complete architecture of the static website that I built. This isn't just a simple S3 website. This is a production grade solution identical to what Fortune 500 companies use. Okay, so the front end architecture is this Amazon S3 primary storage with static website hosting enabled, the CloudFront, Amazon CloudFront global CDN with 218 plus edge locations, the AWS certificate manager with free SSL certificates with auto-renewal, and Amazon Route 53 DNS management with 100% uptime SLA. The backend architecture is Lambda right here, serving the serverless contact form processing, the RESTful API with CORS configuration for the API gateway, Amazon SES or simple email service to professional email delivery system, AWS identity and access management or IAM, serving the least privilege security model, and then DevOps pipeline, GitHub Actions automated CI/CD deployments. I have CloudWatch for monitoring and logging, and S3 has versioning for rollback capabilities, and the complete data flow works like this. Users request the custom domain, which was my case, sethpetty.com. Route 53 resolves DNS to CloudFront distribution. CloudFront checks the nearest edge location, which having 218 plus globally. If content is cached, it's served instantly with sub 100 millisecond response times. If not cached, CloudFront fetches from S3 and caches for future requests. The contact form submissions go through the API gateway to Lambda. Lambda processes the form and sends emails via SES. All traffic is served as HTTPS with automatic HTTP redirects. Why each service matters. S3 has 99.999999999%, 11 nines durability, costs 0.023 cents per gigabyte per month. CloudFront has 218 edge locations, reducing load times by 50 to 80%. Route 53 has 100% uptime SLA with built-in health checks. Lambda is pay per execution, scales automatically, has no server management, and Certificate Manager gives you free SSL certificates worth of 100 plus a year elsewhere. Key optimizations most people miss. Proper MIME types. HTML files served as text HTML, CSS as text CSS, cache control headers, strategic caching for different asset types, gzip compression, all text-based assets compressed before upload, file organization, proper folder structure for CSS folder, JavaScript folder, and images folder. Now, some security considerations. No direct S3 public access. Everything routes through CloudFront. Origin access control restricts S3 access to only CloudFront. cross-origin resource sharing, or CORS, properly configured. Bucket policy follows principle of least privilege. Cost optimization at the S3 level. The beauty is in the details. Standard storage for active content, intelligent tiering for unpredictable access patterns, and lifecycle rules that automatically move old versions to cheaper storage classes. This configuration alone saves 60 to 70% compared to traditional hosting while providing better performance and reliability. And here's the kicker. For a typical portfolio website with 20 gigabytes of assets, we're talking about 50 cents per month in S3 costs. CloudFront, the global performance multiplier. CloudFront is where the magic happens. This isn't just caching. This is a sophisticated global delivery system that transforms your website's performance worldwide. The numbers that matter. There's 218 plus edge locations across 6 continents, sub 100 millisecond response times for cached content globally, 50 to 90% reduction in loading times compared to direct S3 access. Built-in DDoS protection automatically handles attacks. Advanced performance optimizations. HTTP2 and HTTP3 support. Automatic protocol upgrades. Broadly compression superior to gzip. Automatically applied to text assets. Origin Shield. Additional caching layer for highly trafficked content. Edge compute. Lambda at edge for dynamic content at the edge. My caching strategy, this is critical. Static assets, images, CSS, JavaScript, 1-year cache with version file names. HTML files, 5-minute cache for invalidation. HTML files, 5-minute cache with the CloudFront invalidations for updates. API responses, custom cache behaviors for different content types. Error pages, custom 403, 404 handling with proper fallbacks. The security features built in. Security headers, automatic injection of HSTS, X-frame options, CSP, geographic restrictions, block or allow traffic from specific countries, WAF integration, web application firewall for advanced threat protection. SSL termination handles all of the SSL TLS at the edge. The real-world performance impact, I ran tests from 12 global locations without CloudFront. Users in Asia experience 3 to 5 second load times. With CloudFront, those same users now get sub 1 second performance. That's the difference between losing customers and converting them. The custom error page configuration. Here's something most people get wrong. You need proper error handling. 403 errors redirect to custom error page with 200 status. 404 errors redirect to custom error page with 200 status. This prevents users from seeing ugly CloudFront error pages. The result, users anywhere in the world get blazing fast performance, and you're protected against traffic spikes that would traditional host. Professional domain and SSL setup. Here's where we transform from a hobby project to a professional web presence. The domain and SSL setup is completely automated in enterprise-grade Route 53 DNS configuration. Hosted zone management with 100% uptime SLA, A records for root domain using CloudFront aliases, CNAME records for www subdomain redirection, health checks for automated monitoring, SSL certificate automation. This is beautiful. AWS's certificate manager handles everything. Free SSL certificates from Amazon's Trusted Certificate Authority, automatic renewal before expiration, no more manual renewals, wildcard support for subdomains if needed, integration with CloudFront and Route 53, critical implementation detail. Now, the CSSL certificate must be requested within the US East 1 region for CloudFront compatibility. This is a requirement that trips up many developers. Domain registration strategy. For maximum professionalism, I recommend .com extension for broadest recognition and for personal branding. Register through Route 53 for seamless integration. Enable privacy protection to hide personal information. DNS optimization techniques. TTL settings optimized for performance and flexibility. Alias records for AWS resources. No additional DNS lookup costs. Geolocation routing for serving different content by region. Failover routing policies for disaster recovery. The professional impact moving from a CloudFront URL like this to a custom domain like this isn't just cosmetic. It's the difference between looking like a student project and a professional business. Cost breakdown, domain registration, about $12 to $15 per year through Route 53. Route 53 hosted zone is about 50 cents per month. SSL certificate, $0, completely free through ACS queries, 40 cents per million queries. For most portfolio sites, you're looking at $1.50 per month total for professional domain and SSL. And that's less than a cup of coffee for enterprise grade web presence. Real cost analysis. The numbers don't lie. Let's talk real numbers because cost optimization was a major goal. And these numbers will blow your mind. Monthly costs for a complete professional website. S3 storage at 50 cents per 20 gigabytes of website assets. CloudFront, $1.50 per month at 100 gigabyte transfer, 1 million requests. Route 53, 50 cents for the hosted zones and DNS queries. Lambda, 10 cents per 1 million executions, well within the free tier. API gateway, 20 cents per 1 million API requests. SES email, 10 cents for the contact form emails. Certificate manager, completely free, $0, with the total monthly cost of being $2.90 per month. Compare this to traditional alternatives. Shared hosting, $10 to $20 per month with terrible performance. Managed WordPress, $25 to $50 per month with limited scaling. VPS hosting, $20 to $50 per month, requires server management. Premium CDN services, $50 to $200 per month for equivalent performance. Enterprise hosting, $100 to $500 per month for similar features. Enterprise scale example. For a traffic business site serving 1 terabyte monthly, our AWS solution is $85 per month with the global CDN and SSL. A traditional CDN provider would be $300 to $500 per month. Dedicated infrastructure would be $1,000 plus per month, plus management overhead. Free tier benefits, first 12 months, S3 storage, 5 gigabytes, free storage, 20,000 GET requests. CloudFront, 1 terabyte data transfer, 10 million requests free. Lambda, 1 million requests, 400,000 gigabytes second, compute free. Your likely first year cost is under $10 total. The return on investment is insane. Cost savings of 90% plus versus traditional hosting. Performance improvement, 75% faster global load times. Reliability increase of 99.99% uptime. Security enhancement. Enterprise grade SSL and DDoS protection. Scalability, handles viral traffic automatically. Hidden cost savings, there's no server maintenance, 0 IT overhead. There's automatic scaling, no capacity planning required. Built-in backups with the S3 versioning provides instant rollbacks. Global presence, no need for multiple hosting accounts. Here's the kicker. I've heard of companies paying consulting firms $100,000 plus to implement the same exact architecture we just built for under $3 per month. The secret is understanding AWS pricing models and using serverless technologies that can scale with your usage. Complete backend and automation. Now let's talk about the backend functionality and automation that transforms this from a static site into a full stack application. The serverless contact form backend uses the AWS Lambda Python function for form processing and validation. The API gateway is a RESTful API with proper CORS configuration. Amazon SES is the professional email delivery with formatting. Input validation is server-side validation for security. Error handling, graceful error responses, and user feedback. The Lambda function handles form validation required fields, email format, content length, email formatting, professional emails with the submission details, security input, sanitization, and rate limiting protection, logging, complete audit trail of all submissions, auto replies, confirmation emails to form submitters, GitHub Actions CI/CD pipeline. This is where the magic happens. Complete deployment automation. So the professional DevOps workflow. Developer pushes code to main branch. GitHub Actions triggers automatically. Code is tested and validated. Assets are optimized, minification and compression. Files sync to S3 with only changed files uploaded. CloudFront cache and validated for updated content. Deployment confirmation with rollback option if needed. Error handling and monitoring. CloudWatch logs complete visibility into function execution. Dead letter queues handle failed email deliveries. Performance metrics monitor response times and error rates. Automated alerts, Slack email notifications for issues. Health checks and Route 53 monitoring with failover capability. This level of automation means I can push a code, change, and have it live globally within 3 minutes with full confidence that if anything goes wrong, I can roll back instantly. Enterprise grade security implementation. Security isn't an afterthought. It's built into every layer of this architecture. Let me show you the security measures that would cost thousands to implement traditionally. Multi-layer security architecture offers WAF protection. CloudFront includes web application firewall capabilities, DDoS mitigation, automatic protection against distributed denial of service attacks, SSL TLS encryption, all data encrypted in transit with modern protocols, origin access control, S3 bucket only accessible through CloudFront, not directly, identity and access management, or IAM, principle of least privilege. Each service has only the permissions it needs. Role-based access, Lambda functions use execution roles, not user credentials. API security, API gateway with proper CORS and authentication. Audit trails, CloudTrail, logs, all AWS API calls for compliance. The data protection measures. Encryption at rest, all S3 data is encrypted with AWS managed keys. Encryption in transit, HTTPS, everywhere within with HSTS headers. Backup and versioning. S3 versioning provides point-in-time recovery, cross-region replication, optional backup to secondary regions, application security, input validation, server-side validation and Lambda functions, rate limiting, API gateway throttling prevents abuse, error handling, no sensitive information exposed in error messages, security headers, automatic injection of security headers via CloudFront, compliance and governance, SOC 2 Compliance. AWS infrastructure is SOC 2 certified. CDPR considerations. Data processing agreements available through AWS. ISO 27001. AWS data centers meet international security standards. HIPAA eligibility. Architecture can be configured with HIPAA compliance. Security monitoring. CloudWatch metrics. Real-time monitoring of security events. AWS config. Compliance monitoring and configuration drift detection. Guard duty integration. Threat detection and anomaly monitoring. Security groups, network level access control, disaster recovery and business continuity, multi-availability zone redundancies, data replicated across multiple availability zones, global edge presence, traffic automatically routed around failures, infrastructure as code, complete environment recreation in minutes, automated backups, S3 versioning and lifecycle policies, professional security practices, secrets management, environment variables for sensitive configuration, network isolation, VPC configuration for enabled security when needed, certificate rotation, automatic SSL certificate renewal, access logging, complete audit trail of all access requests, security cost comparison, traditional hosting security features, SSL certificate, 100 plus per year, DDoS protection, 200 plus per month, WAF service, 500 plus per month, backup service, 50 plus per month, monitoring, 100 plus per month. Our AWS solution includes all of this for under $3 per month total. That's enterprise grade security at consumer pricing. Critical pitfalls and professional solutions. Let me share the challenges I have encountered and the professional solutions I developed. These insights will save you hours of debugging. Pitfall number 1, CloudFront cache invalidation costs. The problem is frequent invalidations can cost 0.005 cents per bath, and it adds up quickly. The solution: use version file names for static assets. An example: style only invalidate HTML. Best practice: cache static assets for 1 year, HTML for 5 minutes. Pitfall number 2, SSL certificate region requirements. Problem: the SSL certificates for CloudFront must be in US East 1 region. Solution: always create the certificates in US East 1, regardless of your main region. Implementation: use separate AWS provider and Terraform for certificate management. Pitfall number 3, CORS configuration complexity. Problem: contact form fails with CORS errors in browser. Solution: proper options method configuration and API gateway. The critical detail about this is both pre-flight and actual requests need CORS headers. Pitfall number 4, Lambda cold start performance. Problem: first contact form submissions takes 3 to 5 seconds. Solution: CloudWatch events to keep functions warm or accept occasional delays. Alternative: provision concurrency for guaranteed performance, but it does cost more. Pitfall number 5, S3 website endpoint versus REST endpoint confusion. Problem: using wrong S3 endpoint type breaks CloudFront routing. Solution: always use S3 website's endpoint for static hosting, REST endpoint for file access. Format: bucket. The format is bucket S3 website region.amazonaws.com. Pitfall number 6, GitHub Actions workflow failures. Problem: deployment fails with permission errors and timeout issues. Solution: proper IAM permissions for GitHub Actions user. Critical permissions: S3 full access, CloudFront validation, Lambda read access. Pitfall number 7, cost monitoring blind spots. Problem is unexpected usage spikes increase costs without warning. Solution: set up AWS billing alerts and budget monitoring. Implementation: CloudWatch billing metrics with SNS notifications. Implementation: CloudWatch billing metrics with SNS notifications. Professional debugging approach: check CloudWatch logs for detailed error messages. Use browser developer tools to identify network issues. Test each component individually before integration. Monitor AWS Health Dashboard for service-wide issues. Implement proper error handling with user-friendly messages. The emergency response procedure: a rollback plan, Git revert, plus and automatic redeployment. Traffic routing: Route 53 health checks with failover. Performance degradation: CloudFront cache clearing and origin shield. Security incidents: CloudTrail analysis and IAM policy review. Documentation best practices: architecture diagrams, visual representation of all components, runbooks, step-by-step procedures for common operations, troubleshooting guides for solutions for known issues, changelogs, track all modifications with business justification. These solutions demonstrate professional level thinking that separates senior engineers from junior developers. It's not just about making it work. It's about making it work reliably in production. Now, I know you're wondering, how was all of this accomplished? First, let me start by introducing these. So I went through and made documentation so you could follow step by steps on what happened. Basically, it's a 6-phase project and covers the bucket setup with logging into AWS console and going through each step-by-step process of manually doing everything. And I will have all of these included down in the description, so you can just download a zip file that has all of the documentation with it, as well as the infrastructure diagram. Each of the phases to where you can follow along. And do everything step by step. And I'll just show these real quick. And like I was saying at the various points, that the whole manual process of completing each one of these steps took me over 10 hours to do. And mainly why it took so long was when I was setting up the contact form, my contact form was not working correctly and emailing me back. So I had to troubleshoot it, and come to find out it really wasn't something that was broken. It was sending the emails on the back end. However, Hotmail was filtering out the emails before they even hit my email. So I had to set up an alternate email to get it to finally send the automation emails when filling out the contact. And so just wanted to explain that a little bit. But now the moment that you've been waiting for, probably since the beginning of the video, I'm going to show you how we can deploy this entire infrastructure and update content with a single command. I have all automation scripts ready, and and you'll see exactly how powerful this infrastructure becomes when combined with proper automation. This is the culmination of 10 plus hours of development work, turning a complex manual process into one command deployment that any team member can execute. So let's make it happen. All right. So I have already taken the liberty to set up my directory with the appropriate files. So this is Visual Studio right here. So I have all of these Terraform files already made and in their directories from where they need to go. So close that back out. Just wanted to kind of show you that real quick. But I do choose directory, Terraform, portfolio. All right. While that runs that, just want to show here. Right. So as you can see, I only have one bucket that was created in S3. I only have one Lambda function for portfolio contact form. What was the other one? I think it was users as well. Okay, so only one GitHub Actions user. I think this is actually going to stay the same because it's going to create the same user when I go ahead and apply this. All right, so got that running. So here you can see it's doing the API gateway, setting up the Lambda, the S3 bucket And now it's doing the CloudFront. Here and over here. Okay. So here you can see it's creating one right now. Okay. Here you can see it's creating that extra bucket. So it didn't do the rolls yet on this, but come back to the Lambda's homepage. All right. So here you can see it created that function for Lambda. Go ahead and back up to APIs on my API gateway. Here you can see it created the API. Okay, so it's still creating the distribution for this is CloudFront. So while it does that, I kind of want to show you. All right. So doing the CI/CD pipeline, I have the website on GitHub and this open my Visual Studio up again. I'm gonna okay, so anytime all right, so coming back over to the website, this is the landing page for it. So to kind of show the CI/CD pipeline, I'm gonna come back. Well, no, don't need that. All right, so I'm gonna take this file, which is the home page of it, and I'm just gonna make a small change to it where you can see, hello, I'm Seth. I'm just gonna put, hello, I'm Jeff. And then I'm just gonna save this. And when I come over to my GitHub desktop application, it's gonna show that hello, I'm Seth got changed to hello, I'm Jeff. So I'm going to do commit one file to main, and then I'm going to push origin. And then with that being done, if I hit refresh, oh, still got to update CloudFront. There it goes. All right. So it switched it to hello, I'm Jeff. Close that. All right. So everything was fully done now. Come over here. Okay. So here you can see it now and did a new distribution. Gave it a new domain name. The S3 bucket that I created. And I took that 10-hour process turned it into like a 10-minute process. So just wanted to show that process being done, and hopefully you can get a understanding from it. What's built here isn't just a static website. It's a complete enterprise-grade cloud application that demonstrates cloud engineering skills. Architecture summary, what was actually built. The front-end static website with global CDN and custom domain. Back-end serverless API with email integration and form processing. Infrastructure, completely automated deployment and management. Security, enterprise-grade SSL, DDoS protection, and access controls. Monitoring, comprehensive logging, alerting, and performance tracking. DevOps, a CI/CD pipeline with automated testing and rollback capabilities. Professional skills that were demonstrated. AWS cloud architecture, multi-service integration, optimization, serverless development. Lambda Functions in API gateway design, infrastructure as code, Terraform implementation and best practices, DevOps engineering, complete CI/CD pipeline automation, security implementation, multiple layers of protection and compliance, cost optimization, 90% plus savings while improving performance, performance engineering, global optimization and caching strategies, business value articulation, cost optimization, 200 plus per month savings versus traditional hosting, performance improvement, global sub 1 second load times, scalability, automatic handling of traffic spikes, reliability, enterprise grade uptime and disaster recovery, security, advanced protection without dedicated security staff, maintainability, zero server management and automatic updates, next level opportunities, the real success metric. You've built something that would cost 100,000 plus as a consulting project, demonstrates enterprise level thinking, and positions you for cloud engineering roles. This isn't just a portfolio piece. It's proof that you can architect, implement, and maintain production grade cloud infrastructure. Share your implementation, open source your Terraform configurations, write blog posts about your optimization techniques, and help other developers learn cloud engineering. The knowledge you've gained here can help countless others make the transition to cloud careers. Remember, this architecture is identical to what Fortune 500 companies use for their corporate websites. You've just proven you can think and build at that level. Now go show the world what you can do. If this deep dive helped you understand modern cloud architecture and professional development practices, smash that like button and subscribe for more advanced cloud engineering content. Drop a comment below with your deployment results or any challenges you encountered. I read every comment. The complete Terraform code, troubleshooting guides, and architecture diagrams are linked in the description. Everything you need to replicate this professional structure is there. Thanks for watching. I'll see you in the next one. And remember, keep building, keep learning, and keep pushing the boundaries of what's possible in the cloud.